For topic two, we're going to look at multiplying and dividing fractions and mixed numbers, but we're really going to focus on the mixed numbers. We already learned how to multiply and divide fractions in a previous section. So for this section, the main focus is going to be those mixed numbers, but a lot of that stuff from the previous section still applies. Okay? So steps to multiply and divide mixed numbers. First and foremost, you absolutely have to convert them to improper fractions. Unfortunately, this is non-negotiable. You have to do this. Okay, when it comes to adding and subtracting mixed numbers, you have options, but here with multiplication and division, they must be in fraction form, not mixed numbers. Okay, so convert your mixed numbers to improper fractions and then just follow the steps that we learned in section 3.3 for multiplying and dividing fractions. So that would be number one, convert to multiplication. So if you're already dealing with multiplication, no big deal. But if you're dealing with division, you have to convert it to multiplication, meaning if we have A over B divided by C over D, we leave the first fraction the same, and then we multiply by the reciprocal of the second fraction. So that would be A over B times D over C. So that's your first step. Two, cancel common factors, top versus bottom. And by cancel, it just means divide out common factors. A lot of times mathematicians get really lazy and we use the word cancel. We just throw it around. Okay. We're like, here's a cancel, there's a cancel, you get a cancel, you get a cancel, everybody gets a cancel. Okay. Cancel in math means two things. It doesn't mean anything just like poof disappears. It means that things divide out to become one or they add to become zero. Okay. So in this case, when we say cancel common factors, it just means divide out common factors. Okay. And then the third step is we multiply across. Okay. So step one, you must convert your mixed numbers to improper fractions and then just follow your regular steps for multiplying and dividing fractions. Okay. So for example two, it says find each product. Okay. So for part A, we have 1 and 2/3 times 11/15. So the very first thing we need to deal with is the 1 and 2/3. So kind of off to the side, I'm going to convert 1 and 2/3 to an improper fraction. So if you have 1 and 2/3, the way we would convert this to an improper fraction is you take your denominator times your whole number, and then you add your numerator and then you put it all back over the original denominator. So 3 times 1 is 3, plus 2 is 5, and then we're going to keep it over 3. So this is really 5/3. And then we're going to multiply that by 11/15. Now, as you continue to work with fractions, I want you to get stronger at simplifying your fractions as you go when you're multiplying and dividing, but it can be a little tricky at first, okay? So what I'm going to do now is I'm going to rewrite this and I'm going to write the two numerators over the two denominators, but this denominator right here, this 15, it's not a prime number, so I'm going to rewrite it as a factorization, okay? So this is equal to 5 times 11 as the numerator, all over 3 times 15, but I'm going to write 15 as 5 times 3. So we have 3 times 5 times 3. And this right here, well, let me do a different color. This right here really just equals the 15. So we just kind of broke 15 into two factors. And then what we can see by doing this is we can see that the numerator has a factor of 5 and the denominator has a factor of 5. So we can divide those out. And what that means is we're going to take 5 and divide it by 5, and then we're going to take 5 in the denominator again and divide it by 5. So we're saying, hey, the numerator is divisible by 5. 5 divided by 5 is 1. The denominator is divisible by 5. 5 divided by 5 is 1. And then we just clean things up. Okay. So in the numerator, I'm left with a factor of 1 and then a factor of 11. So 1 times 11 is just 11. And then in the denominator, I'm left with factors of 3 times 1 times 3. So 3 times 1 times 3 is 9. And then here's a good rule of thumb. If your problem is just like a really generic problem like this, if you started with a mixed number, you should end with a mixed number. So I would go ahead and rewrite this as a mixed number. So here's how you can do this kind of quickly. Ask yourself, how many times will 9 go into 11 evenly? Well, 9 will go into 11 one whole time. What's left over? Well, there'd be 2 left over, so we get 1 and 2 ninths. Now, if you're going to do the long work for that, that's fine. We would take 11 and divide it by 9. How many times will 9 go into 11? It goes in once. We take 1 times 9 and subtract it, and we get 2. This is your whole number. This is your numerator. And then this is going to stay the denominator. So we get 1 and 2 ninths, and that would be our final answer. Okay, now for part B, we have 3 and 1/5 times negative 2 and 3/4. So let's do a little work to convert both of those to improper fractions. So if I have 3 and 1/5, I take my denominator, I multiply it by my whole number, so 5 times 3, add your numerator, and then keep it all over the original denominator. So 5 times 3 is 15. 15 plus 1 is 16, and then we keep the 16 over 5. Okay? Now for the second number, we have 2 and 3/4. Don't worry about the negative. Like the negative is not part of this calculation we're about to do. We just want to keep the improper fraction negative. So we're going to convert 2 and 3/4. So remember, denominator times whole number. So 4 times 2 plus the numerator. So 4 times 2 plus 3 all over the original denominator. Well, 2 times 4 or 4 times 2 is 8. 8 plus 3 is 11. So we're going to get negative 11 over 4. Okay? And so what I'm going to do now is I'm going to rewrite some of these numbers. Okay? I'm going to leave 5 alone. I'm going to leave 11 alone. I'm going to leave 4 alone. Even though it's not prime, I'm still going to leave it alone. I'm going to rewrite my 16. Okay? So let's talk first about signs. We have a positive times a negative, so we know that's going to end up being negative. So I'm just going to bring the negative to the front. I'm going to rewrite 16 as, my voice just cracked. I'm going to write 16 as 4 times 4. I'm going to leave the 11 as is. I'm going to leave the 5 and the 4 in the denominator as is. And hopefully now what you can see is there's a common factor of 4 in the numerator and the denominator. So we would take a 4, divide it by itself, we get 1. 4 divided by itself is 1. We clean things up. The whole answer is still negative. So make sure you bring that negative over. And then in the numerator, I have 1 times 4 times 11. Well, 1 times 4 is 4. 4 times 11 is 44. And then my denominator, I get 5 times 1, which is 5. And again, if you start with mixed numbers, it is totally normal to write your answer as a mixed number. So if you want to do the side work, you take the numerator divided by the denominator. So we ask ourselves, how many times would 5 go into 44? Well, 5 would go into 48 times. So 5 would go into 44 8 times. 8 times 5 is 40. We subtract and we're left with 4. So the way this works is we do the quotient as the whole number. Just don't forget to bring your negative over. So we get 8. The remainder is your numerator. And then the divisor just stays your denominator. So we get 8 and 4/5. So basically 5 goes into 44 8 whole times with 4 out of 5 left over. Okay. And just make sure with a situation like this, you kind of address your sign right at the start. We had a positive times a negative. When you multiply one positive and one negative, you get a negative. You just have to carry that negative throughout all your side work. Okay. Now, for example 3, we're going to find each quotient. And remember, when you're dealing with division of fractions, if we have A over B divided by C over D, we leave the first fraction alone, and then we multiply by the reciprocal of the second fraction. So we would multiply by D over C, and then just follow your steps for division, okay? Or for simplifying the rest of the answer, I guess. Okay, so find each quotient. We have 4/9 divided by 7. So first of all, the good news is we don't have to convert anything to a mixed number, but we do have to deal with this 7, okay? I don't like having just a plain old 7 there. It's going to cause us problems in just a little bit if we leave it as just a plain old 7. So what I'm going to do is I'm going to rewrite this problem as 4/9 divided by 7, but I'm going to write 7 in fraction form. I'm going to write it as 7/1. This way, when we go to write this as multiplication, we have a distinct numerator and denominator, so we can pretty easily find our reciprocal, okay? So remember, with division, first fraction stays the same, and then we multiply by the reciprocal of the second fraction. The second fraction was technically just 7. We wrote it as 7/1. The reciprocal of that is 1 over 7. Okay, so be on the lookout for that when you're dealing with division and a whole number pops up. Okay, you can still write it as a fraction by just putting it over 1. Okay, so now I have 4/9 times 1/7. 7 is prime. 9 has factors of 3. 4 has factors of 2. There are no common factors top to bottom. So in this case, I can just multiply it across. So I get 4 times 1. That's going to be my numerator. And then 9 times 7 is 63. And that ends up being your final answer here. Nothing's going to reduce. Okay? Now, part B is going to be a different critter. Okay, so for part B, we have -3 2/7 divided by -2 3/14. We got to do a little bit of work here, okay? First things first, let's just talk about signs, okay? What happens when you divide two negative values, okay? Well, the rules are this. If you multiply or divide one positive and one negative, the result is negative. However, if you multiply or divide two numbers that have the same sign, both positive or both negative, the result is positive. So we know we're going to get positive something. Okay, so I'm just going to kind of keep everything positive from this point on because we know the final answer is going to be positive. Okay, so let's first convert these to mixed numbers to improper fractions. So we have 3 2/7. And remember, the rules for converting a mixed number to an improper fraction, you take the denominator, multiply it by the whole number, add the numerator, and then keep whatever the original denominator was. So 7 times 3 is 21. 21 plus 2 is 23. So we end up with 23 over 7. And again, I'm just going to keep it positive because I know at the end of the day, my final answer is going to be positive. All right. Now let's do the same thing for -2 3/4. Again, I'm just going to keep it positive. So I have 2 and 3. I think I said 3/4. It's actually 3/14. So 2 and 3/14. We keep the denominator times the whole number, add the numerator, so we get 14 times 2 plus 3, and we're going to put that all over 14. So let's see, 14 times 2 is 28. 28 plus 3 is 31. So we end up getting dividing, we're going to get division of, let's see, 28, 31, yeah. So we get divided by 31 over 14. Okay, I had to stop and think about that one for a second. Okay, so 23 over 7 divided by 31 over 14. First thing I need to do is convert this to multiplication. So the first fraction stays the same, and then I multiply by the reciprocal of the second fraction. So I'm going to multiply by 14 over 31. Okay, now hopefully you're getting better at simplifying. We're looking for common factors. Okay, so one thing that hopefully you recognize pretty quickly is that 7 and 14 are both divisible by 7. They have a common factor of 7. So instead of writing out factorizations, what we can do is just acknowledge, hey, 7 and 14 have a common factor. So if I take 7 and divide it by itself, I get 1. If I take 14 and divide it by 7, I get 2. Okay, now 23 is prime, 31 is prime, nothing else is going to simplify, so we can go ahead and multiply across. So I get 23 times 2, which is what, 46? And then I get 1 times 31, which is 31. And again, just like what we've done with the other three examples, well, two of the other examples, if you start with mixed numbers, it is very common to end with a mixed number, okay? So I would want to write 46 over 31 as a mixed number. So we ask ourselves, how many times would 31 go into 46? And it would go in one whole time. And if we subtracted 31 from 46, we'd be left with 15. So the final answer here would be 1 and 15 over 31. And it would be positive, remember, because we started out with division of two negatives, okay? Now, if you need to see the work to convert this back to a mixed number, you would take the numerator, divide it by the denominator. 31 will go into 46 one whole time. We would then take 1 times 31 and subtract it. And then when we subtract, we get 6 minus 1 is 5, 4 minus 1, or 4 minus 3 is 1. So we get the whole number, the numerator, and then this just stays the denominator. And that is multiplying and dividing mixed numbers. So the big thing here is if you can multiply and divide fractions, you can multiply and divide mixed numbers. You just have to remember to convert them to improper fractions first, okay?